Good afternoon, class. Hello again, and today we're going to continue from where we ended in our previous two lessons. And the first lesson gave you an introduction on what machine vision is and its application, as well as the pipeline when you're developing, like from the how you take your input to how you process the input to the model development stages. So it gave you an introduction. Then we saw how we can different libraries that are common when you're reading and handling images. So the first part we dealt with how you can read images, and we saw two libraries, the Pillow library and the OpenCV library. So in this class, we're going to continue where we ended last time, I'll say now, after reading the images or converting into grayscale, perform any image processing operation, then you would be required somehow to save your images. So either you save as intermediate results, or you can save as the end, like these are the end results. So intermediate, you can save maybe if you have resized your images when you're doing some image operations, resizing, or you've changed the color format, or you've changed them into grayscale, then you can save your images into a specific directory or in the current working directory for using them into other operations. So we'll begin with how you're going to save the images, and we'll use the OpenCV library. And when you're saving the images now, the methods that you're going to use is the ImWrite method. We saw when you're reading, you use the ImRead methods. Now, when you're writing in OpenCV, you use the ImWrite method. So we'll begin with first knowing what the ImWrite methods, the arguments that it accepts. So the ImWrite methods accepted two arguments. The first argument is the file name. So it will accept the first argument as the file name. So if you're working with Jupyter notebooks and your images, maybe you want to read your images that are in the same working directory. So you just need to write its name and specify the image format. But in case it's a different directory, you need to specify the whole file path where you find where the image is. And the second argument is the image that you want to write, or the image that you want to save. So to begin with, we may delete this. So let's begin with an example. Maybe you want to read an image that has been saved in a current working directory. So if you have already successfully installed your OpenCV library, the first thing you need to import is the CV2 module. So you'll import the CV2 module. After that, because for this practical, for this exercise, I want to read an image, then convert it into grayscale, then I'll save the image. So I'll show you how you can save that new image that has been converted into grayscale. So the first thing that I'm going to do is read the image. So let's call that image that I want to read like let's say, call it image 2. So you want to save image 2. The first thing that I'm going to read it, so I can even write a comment here so that when you're going through this tutorial, it's easy for you. So we'll first start by reading the image. So reading the image from the working directory, from the current working directory, and like that, in short. So, because I'm reading the image from the current working directory, then I'll use the ImRead method, like we saw before in the previous class. So the ImRead method takes an argument, which is the name of that image. So this is my working directory, and let's read an image. Let's read this image, capture, the PNG. So, so let's read that. So capture, and I'll specify the format of that image, which is a PNG file. And after reading, like in the previous class, let me display it so that you can see it in a pop-up window. So the first, I'm going to use the I'm show method. So cv2 dot I'm show to show the image by using a pop-up window to pop up. So the first method that you it also takes 2 arguments. The first argument is the name of that window. Let's call it window 2. Let's call that window 2. Window 2. And the second argument is that image that you want to display. For our case, we want to display this image. So it's called into image 2. After that, because this is a pop-up window, you need to close it. So you need to specify after some specific time or period, it needs to be closed. So I'll use the wait key to take an input from the keyboard. So cp2.im the wait method, wait key method. So it will take just let's say that's 0 to wait for some time, and then destroy the windows, all the windows that have been. So we'll use the cp2 to destroy all windows to destroy any window that has popped up. So destroy all windows. Okay, so let's do this and let's see if we can this capture. We can display this. Read the image as well as let me comment also this part. After reading the image, then this is displaying the image in a pop-up window. The image in a pop-up window. So let's run this code. Okay, run this. And here is the image. Let me also share this screen. Sharing the screen so I can window 2. So also share this. So you can see that this window is also being shown here. So this is the window that we have read the image, which is called capture.png. Then we have displayed it in a pop-up window, which is the window. We called it window 2, the name of this window. So this is window 2. And what we're displaying here is this image that we have read it here. So this is how you can read an image and display it in a window using the I'm show method of the cv2 module. So destroy all, it will accept a keyboard. I mean, if I close here, so it will. Okay. So we can also let's see. Let me share another screen. So let me share this one. So we can go back to where we are. So we have what we have read, the capture.png and we have displayed the window where the ones that we have already. In the window name, we gave it a window 2 as its name, and we've displayed this image. So what if I want now to save an image, the same image, but I'm going to convert it into a grayscale image and then save it using the IMWrite method. So let's add another code. So because we've already imported the cv2 module, there's no need to import it. So I'll just go to converting into, let me say, grayscale image. So gray, let me call it gray 6. You can call it any name. So we also use the cv2 method, and like the previous class, we need to convert the color of this into a grayscale image. So it also takes 2 arguments. The first argument being what we want to convert into gray. So we're going to convert the img2, this image that we have read here. And the second argument is the method, how to convert it into grayscale. So like the previous class, just a repetition. So like I said, the OpenCV saves the image in the BGR format. So it will convert, we are going to convert BGR to gray. So the gray, and before, we can also display this. Let me just copy this because it's just the same thing. I'm going to paste it here. Let's call that maybe window 3. And what we are going to display is this gray 6 image. So grace6 and the wait key and the destroy windows after to close the windows. So let's run this. So this is the grayscale. Let me share the screen and so that you can also see this. So you can share the screen. So this is the grayscale image. I hope you can also see this. Okay. So this is the grayscale image that we've converted. Before it was just the colored image in BGR format, and now this is the grayscale image. So, and we've converted it, we've called it window 2.3. Yeah, so that's the pop-up window. So let's proceed with sharing my screen. And so let's go to, now what we have done is read an image, display it in a pop-up window, and convert it into grayscale, and also displaying the grayscale image. So what if I want to save now the grayscale image in our working directory? So what I'll do, I'll add another code, and let's say, let me call it save image for us. Save to. This will take and what will take the first save it to the IAMWrite method. So IAMWrite, it takes two arguments like we've seen before here, like the first one being the file name. So like I said, if you're working in the same working directory, you just need to specify the name. So let me call it, let's call it grayscale image 2. Grayscale 2. So let's call it grayscale 2. This is the name, and we need to specify the image format. And this is the first thing. And what we are saving exactly, we want to save this image here. So the grace6 is the one we are saving, and this is its name. This will be the file name in our file system. So, and it will return true. If the image has been successfully saved into our file system, it will return true. So we can also print the status. So let me print save to, meaning that I want to print the status. So if it has been saved successfully, it will return true, and the image will be saved in our file system. So so true meaning that it has been saved. So let's go and look for an image in our file system that is called grayscale 2. This is where I'm aiming. So this is the image is here. So it has been saved seconds ago, meaning that after I click save, it has been saved. So that's how you read an image. You can do other transformations, and then you can save it in your file system. Remember, you use the IAMWrite method, and it takes two arguments, and it returns the true value if image has been saved. And the first argument will be the name. And remember that if you don't want to save it in your working directory, you can specify the whole path plus the name of that image and its file format, and you save it into your file system where you want to save. And the IAMWrite method you can store in any storage device depending on how you specify it. So that's how you save an image or writing an image. So then we can go on now. All these examples required you to create a pop-up window and then specify some waiting time, then destroy the window. So what if you want now to just display the image in your working in your notebook? So what you do is that you use a certain powerful visualization library known as the Matplotlib library. So this is our Matplotlib library, and what it does, it's a visualization library, and it shows the 2D plots of what you want to display. So if it hasn't been installed in your machine, and if you're using Anaconda, this is the easiest way. You can use the Conda install in the command window of the Anaconda, and you can install by using this this command. So okay, now Matplotlib is really important because at some time, maybe if you're working with many images, then you want to, maybe you have transformed them, either rotated them or change their color or resize them. It depends on what you're doing into the images. And especially if you're doing what is known as data argumentation, which we'll see later in the course. You want to display, you see how your images are. If you have cropped them, you want to see, okay, if I've cropped them, have I really done a good job, or I've just taken out some really distinguishing features that can help in training my model. So what you're going to do is that you'll have to visualize them. So visualizing them in your notebook is when the Matplotlib library now becomes handy. So the first thing that you have to do, if you've already successfully installed it in your machine, you need to import the library. So you use the import Matplotlib .pyplot and as PLT. So whenever you use it, you just use PLT. It becomes easier. So as PLT, you can say that. Import Matplotlib pyplot as PLT. So because I want to just show you, I want to read this image. I mean, display this image that I've read here, image 2. So what I'm going to do is that instead of, so because I've imported it as PLT, so I'll just use PLT.show, I'm sure. PLT.ImShow. What I want to show is the image 2. I want to show this image. So I want to show this image, and then PLT.show. So this one will show it on my Jupyter notebook just below this code as an output. So yeah, so let me run this. So you can see, this is the image that I have read and displayed it using the Matplotlib, and you can see it's just being displayed here below the code. So meaning that it's displayed in our Jupyter notebooks. And you can see that the image, it's in BGR format. If you saw the original images when we plotted it, it's RGB format, meaning that it is colored. Let me show you. So OpenCV displays the images in BGR format, meaning that the B is more enhanced, the blue is more enhanced, right? So if you want to get your original images as how it is you have to convert it into RGB, because that's the format that most images are. So you need to convert it into the normal RGB, red, green, and blue. So what you do, as the way you converted into grayscale image, you need to convert it into RGB, the same. So let me add some code here and show you how you can do that. So you can say, let me call it RGB1, and this is the RGB1. I want to convert it into RGB. So like before, need to convert color. What are we converting? Want to convert the image to, because it's being displayed as a BGR format, image 2, and convert it into the standard RGB. So color, which is in BGR to RGB. So this is the one that you use. So if I want to, we can also display this in our notebooks. Let me just display it here instead of in a window. So I'll use the Matplotlib because I've already imported it. There's no need to import it again. So PLT.ImShow. I'm going to show the RGB one, this image that I have converted into RGB, and I'm going to plot it on my machine. So I can do this on my Jupyter notebook. So let me do that, and you can have an error here. Sorry, I didn't color dot. I didn't do this. So this is the original image. So the original image is in RGB format. You can see the color, all the colors, the RGB are highlighted, but this was in BGR format. So if you want to display all your images in the color that you want, I mean the RGB format, if you're working with RGB, So this is how you can do it. So this is how you can convert, and this is how you can use Matplotlib to show your images. So this is what I wanted you to show, saving an image and plotting the images in Matplotlib. And this is handy because we'll work with more images and you'll see where how you can use such knowledge. So yeah, so that's the part I wanted you to show in this exercise, I mean in this part of the lesson 2B. And I've included some practice exercise where you can read an image from any directory in your computer, do this, then convert the image into grayscale, and you can try saving your image in your working directory and also saving in another part of your file system, and also plot the image using Matplotlib. So you can do both in Jupyter Notebooks. Also try reading an image from your drive using the Google Drive. And for this part of the lesson, we can end here. And next part of the lesson, we'll see how you can read now videos. We've talked about images now. We'll also say that in machine vision, we also have to take in videos as input. So we'll see how you can read a video either from your web camera or if it's a camera connected to your computer, and or if you're reading a video file that is stored in your file system. So that will be the next part of the lesson. So let's end it for now. Then I welcome you all to the next part of the lesson. So thank you.